Hi geometers, this is Ms. Feetsum. Let's talk about simplifying square roots. So first I listed down some perfect squares in purple, and what I did was I just took some positive integers and squared them, and you could continue this list on forever and ever, but we're really going to use this list a lot when we simplify square roots, except for we don't really need to worry about the 0 and the 1. Okay, so our first example, we want to simplify the square root of 20. And when you read those directions, simplify, they're not asking you for a decimal approximation. Instead, they're asking you for like simplest radical form. So first I asked myself, is 20 a perfect square? Well, no, it's not in our list in purple before. So then I asked myself, well, does 20 have any factor that's a perfect square? In other words, is 20 divisible by any of the numbers in my perfect square list? And the answer is yes, 20 is divisible by 4. So I'm going to go ahead and rewrite the square root of 20 as the square root of 4 times the square root of 5. Because 4 is a perfect square and 4 times 5 is 20. And it is really important here that I pick a perfect square number for one of my factors because that's going to allow me to simplify it in my next step. Okay, so to simplify this, the square root of 4 is 2, because 2 times itself, or 2 squared, is 4. And then the square root of 5, I'll go ahead and rewrite. Then I always ask myself, can I simplify it any further? So does 5 have any factor that's a perfect square? Is 5 divisible by any of those perfect square numbers? No, so my final answer is 2 times the square root of 5. On our next one, the square root of 162, we need to figure out, is 162 divisible by any of those perfect squares? And you can kind of guess and check it in your calculator if you need to for these bigger numbers. And so I can just go ahead and guess and check some of these. 162 divided by 4 gives me a decimal, so no good. 162 divided by 9 is 18. Okay, so I'm going to use the perfect square factor of 9. So that means I'll write root 162 as root 9 times root 18, because 9 times 18 gives us our 162. And then the square root of 9 simplifies to 3. The square root of 18 I carry down. And then I ask myself, does it simplify anymore? Well, root 18 does, because 18 still has a perfect square factor. It's divisible actually by 9 again. So I could rewrite 18, or root 18, as root 9 times root 2, and I'll just carry down that 3 out in front. And then root 9 is 3, root 2 I carry down, and these are all really being multiplied. So altogether I have 3 times 3 out front, so 9 out front times root 2. Now this is a good example of one where the way that I did it, I went ahead and kind of simplified twice, like I found a perfect square factor here and then again down here. You could actually shorten it up if you had found a bigger perfect square factor. 162, I think, is actually divisible by 81. Yeah, because 81 times 2 is 162. So I could have instead started it out by doing root 81 times root 2. Root 81 is just 9. Root 2 I rewrite, and then I'd be finished. So it's up to you to decide if you want to invest more time up front trying to get the biggest perfect square factor and then just having kind of a shorter problem, or if you're okay with getting any perfect square factor and then just keep simplifying until it won't simplify anymore. Okay. So this next problem, we're squaring an expression that deals with a radical. Well, squaring a number is just the same as multiplying that number by itself. So I'll go ahead and write this out side by side, and then I can multiply the numbers out front to get 9, multiply the numbers underneath the radical, root 5 times root 5. I'm going to write that as root 25 for right now. So the numbers underneath the radical get multiplied, and you write those underneath the root, and then the numbers out front of the root multiply, and those get written out in front of the root. So the square root of 25, I think that actually does simplify. That's just 5. So my final answer, 9 times 5, is 45. Notice another way to do this problem is to do 3 squared times root 5 squared, or in other words, 3 squared is 9, root 5 squared, the square root and the squaring kind of undo each other to just give us 5. and then again we're multiplying, so 45. And just to kind of make sense of why are we multiplying, well, when they don't write the operation in the 3 root 5, it's assumed to be multiplication. Just like when you see 3x, that's 3 times x. So our next few problems have to do with fractions, and specifically the case where you have a square root in the denominator of a fraction. So many times we don't consider an answer like this a final answer or fully simplified because it has a square root in the denominator. It kind of historically comes from before calculators to approximate square roots, you used tables of values, and those tables only had square roots written in the numerator. But it is still nice for us, even now that we have calculators, because rewriting this so that no square roots appear in the denominator will actually allow us to get a unique answer and then be able to check our answers with each other. Okay, so we want to go ahead and rewrite this so that there's no square root in the denominator anymore. So what I'm going to do is I'm going to multiply my fraction by 1, but I'm going to write that 1 in a special way. I'm going to write that 1 as root 6 over root 6. So notice because numerator and denominator are the same, that is equivalent to 1. And the reason why I want to do that is because when I multiply my numerators, I'll get 4 root 6. And then the real magic happens when I multiply my denominators. Root 6 times root 6 is root 36. And notice root 36 simplifies nicely. That's just going to be 6 down in the denominator. So then at this stage, you think, well, can I simplify any more? Can I simplify that root 6? No, 6 doesn't have any perfect square factor. Can I cancel anything from the 4 and the 6? Yes, I can cancel out a factor of 2. So my final answer for this one is going to be 2 times root 6 divided by 3. Okay, the next one I have for you has a square root in the denominator as well, and it has a root 12 in the denominator. Now, you are welcome to go ahead and multiply by root 12 over root 12 right off the bat and simplify it that way. Me personally, sometimes I prefer to simplify that square root and then rationalize at the end. So if I simplify root 12 just off to the side, 12 has a perfect square factor of 4, so I can write it as root 4 times root 3, so that reduces to 2 root 3. So my problem is really 5 divided by 2 root 3. And then when I rationalize, I just actually need to multiply by root 3 over root 3, because this 2 being in the denominator, that's not the problem. It's the square root that I no longer want to be in the denominator. So then in the numerator, we get 5 root 3. In the denominator, we get 2 times the square root of 9. Well, in that denominator, root 9 is just going to be 3, so we really have 2 times 3 in the denominator, or 6 in the denominator. And I just go ahead and check, does root 3 simplify anymore? Nope. Did the 5 over 6 cancel at all? Nope. So our final answer is 5 times the square root of 3 over 6. Okay, just one more for you. I wanted to point out that if you have square roots in the numerator and denominator, you're totally allowed to cancel that before you rationalize. So this one actually works out really nicely if you cancel first, just kind of by coincidence. So the 3 and the 12 are both underneath roots. 3 and 12 have a common factor of 3, so I'm going to go ahead and cancel that out to get root 1 over root 4, and then notice root 1 is just 1, root 4 is just 2. So if you cancel out things first, you don't actually need to rationalize at all. And I don't remember if I explained that vocab term. This process that we used, like in this example, when we multiplied by the root 3 over root 3, to rewrite so that we no longer had a denominator that had a square root, we call that rationalizing the denominator, because we've now made our denominator a rational number, 6, like a non-square root number. Okay, thanks for watching.